Hey guys, my name is Tyler Morrison. I am a biomedical engineering graduate student at Louisiana Tech University, and today I'm going to talk to y'all about gold bionanosensors, or nanobiosensors, however you want to say it, and how they can be used to diagnose and treat cancer. So why do we use gold nanoparticles when doing this? Well, there are three main aspects of gold nanoparticles that make them ideal for cancer treatment. First, gold nanoparticles have superior optical properties. This mainly means that they can effectively scatter light when exposed to it. This way they can be easily located within the body. Secondly, they are very biocompatible. So the body doesn't negatively react to them when they're injected into the bloodstream. They also have some antioxidant and anti-carcinogenic properties. More importantly, these particles can adhere to biological material easily. Thus, antibodies and drugs can be attached to them. Thirdly, gold nanoparticles are easily tunable towards a specific surface plasmon resonance. What this means is that there are certain wavelengths of light that gold nanoparticles transition from scattering that light to absorbing the photon energy, which results in a heat generation, which can be used for photothermally destroying cancer cells. So by changing the nanoparticle shape, this resonance can be tuned, and mainly is tuned towards the near infrared light region, which is around 750 nanometers to 950 nanometers. This is where light absorption isn't interrupted by the bodily tissue. So let's go into the shapes of nanoparticles that are being heavily researched, and then we can determine which ones are best for cancer treatment. First, there are gold nanospheres. There are also gold nanorods, gold nanopopcorn. I couldn't find a good picture of the gold nanopopcorn, so I channeled my inner child and I made one out of Play-Doh. That's kind of what it looks like. Also, there are gold nano cages, which are pretty cool and they can actually be easily made. They look like this. It's pretty rough, but that's kind of what they look like. Right now, it appears that gold nanorods and gold nano cages are taking the forefront of cancer treatment. Gold nano cages are really being researched in breast cancer, mainly because gold nano cages and gold nanorods have a larger surface area than the other ones, so they can have more biomaterial put on them. Also, their surface plasma resonance is better than any of the rest of them, and is in this near infrared light region. So how do we turn these gold nanoparticles into effective biosensors? The concept is actually pretty simple. We attach antibodies that are targeted to specific types of cancer, inject them in the bloodstream, they go through and they find and accumulate at these cancer cells. Typically, they're just coated onto these nanoparticles and allowed to self-assemble around the nanoparticle. So you end up getting something that looks like this. Maybe not exactly like this, but the idea is there. A gold nanoparticle surrounded by antibodies. Now these will be injected into the bloodstream, they'll go through, they'll find the cancer and accumulate at those cancer sites. Once the nanoparticles have accumulated at these cancer sites, they can be exposed to a certain wavelength of light. Those particles will scatter that light and give back a reading as to the location of these cancer cells. That's basically the biosensor part of it. Now for the treatment part of these nanoparticles, we can photothermally destroy these cancer cells through these nanoparticles. And what that means is we expose them to certain wavelength of light, they heat up, and they burn these cancer cells through. So I've kind of done a little example using stuff I found around my apartment. So here goes.
So let's say you have all these nasty little cancer cells take the form of delicious butter. Okay, so now add your gold nanoparticles. That's way too much, but okay. And then put the napkin over to simulate tissue. Now take your near infrared light and burn them up. So let's take a look. Cancer cells are all destroyed, and I'm just realizing I should have made some popcorn.
So let's talk about the drug therapy aspect of it. Basically, it's the same idea. You take your gold nanoparticle with your targeted antibodies, and you coat, say, some chemo drugs on there, right? Putting the chemo drugs on. By using these gold BioNanosensors with the chemo drugs attached to them, you can actually limit the amount of collateral damage done to cells surrounding those cancer sites, as well as increase the amount of cancer drugs that go towards those specific tumors or cancer cells. This will destroy the cancer a whole lot faster and more efficiently. Basically, that's Gold Nanobiosensors in a nutshell. I hope you learned something, and thanks for watching.